You are from student, doctoral student?
Yes, yes, doctoral student.
Doctoral student. Okay, and where are you at the moment?
I am in my country, Papua New Guinea.
Oh, so you still in your country, yeah, in Papua
Yes,
New
yes.
Guinea, yeah. Thank you very much. So you have some issue with the signal?
Yep, yep.
Okay, that's
Am I part of this class or? I think seems like all my classmates are not online.
yeah.
Are we allowed to join?
Yes. Definitely, you are allowed, completely allowed to join. Yeah, feel free. Yeah, the guys lecture is open for all of the students and also for the lecturer. Yeah, don't worry, Joseph. Yeah,
Okay, thank you
enjoy
very
your
much. Thank
time.
you very much.
Okay. Yeah. Okay. Thank you, Pak Suberno and Pak Suberno.
From Unsud, S3 Unsud.
Oh, you are from other university, yeah, from Universitas Jenderal Sudirman. Yeah, thank you for coming.
Okay.
And yeah, please give the greets to our speaker, yeah, Dr. Adeleye. Yeah. Okay. So before we start our lecture, yeah, from Dr. Adeleye. Firstly, I would like to invite our head of department to give some welcoming remark for all of us. Bapak Dr. Rosanto, the time is yours.
Yeah, thank you very much, Pak Mubin. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
First of all, I would like to welcome to our guest lecturer, Dr. Ngozi Adeleye. Good morning, Doctor.
Good morning, Dr. Rosanto. Thank you.
Good morning, all students, scholars, participants, ladies and gentlemen. Thank you to everyone for joining this guest lecture today. First of all, it is such an honor for me to speak on behalf on Economic Department, Universitas Airlangga. And once again, I would like to warm welcome to our guest lecture to our campus, Faculty of Economic and Business, Airlangga University. Although it is online, Dr. Ngozi Adeleye from Convenant University, Nigeria. I would like to express my appreciation to Dr. Ngozi Adeleye for your time to share insight, knowledge about quadratic modeling in applied research, benefit and usefulness. Thank you again very much for your time, Doctor. I think this topic is very useful, yeah, for our scholars, for our students that will use econometric as economic tools for the research. The audiences of today's lecturing are mainly from students, especially from those who took econometrics, development economy class, and from undergraduate, master graduate, and doctoral degree student, and also from the lecturer of Department of Economics and other faculty members from our university and also from outside university as well, because we invite also this invitation to other WhatsApp group, that consists of the lecturers from other university. We wish that this collaboration can continue with other collaboration, Doctor, maybe such as joint research, joint publication, more academic and guest lecturing in our campus in the future. And also For your information, Dr. Ngozi Adeleye and participants, our Department of Economics now, based on QS ranking, we are now in a position of 251 rank in the world by subject of economics and econometrics, and #1 rank in Indonesia, in our country. So we will improve our quality of academic and research and publication in our university, in our department, that we perhaps under 100 rank in the world. So I also have a message from our institution, from our rector, that we expect our institution will improve to the world-class university, with using QS ranking in less than 100 rank. So I hope everyone will participate with this achievement next year. I also would like to express my sincere gratitude to maybe Dr. Kabiri for our contributing colleague to keep in touch with Dr. Ngozi Adeleye, and Pak Mubin for being moderator, and also Pak Wahyu, Bu Haura, and Bu Yesi, and others for arranging this guest lecture. This event would not be done without their hard work. Finally, I will hand it over again to our MC, Pak Mubin, to start the guest lecture. I also would like to apologize to Dr. Ngozi Adeleye and all audiences that I cannot fully attend this guest lecture fully, although I really would like to, because I have another agenda to attend. Once again, welcome and thank you very much for attending this event. Assalamualaikum warahmatullahi wabarakatuh.
Okay, good morning. Waalaikumsalam warahmatullah. Thank you, Bapak Dr. Rosanto, our head of Economics Department, Faculty of Economics and Business, Universitas Airlangga. And I would like to give my greetings. Hello, Professor Cipto Hadi, our senior professor in the Faculty of Economics and Business. It's an honor for us that you join us this morning, Professor Cipto Hadi. And it seems the participants this morning is very enthusiastic from all over the world, Dr. Adeleye. As you can see, some of them are from India, and
I can see Dr. Usman. Wow.
Yeah, you can see Dr. Usman as well.
Yeah, I know Dr. Usman. Wow.
Yeah.
Amazing.
And Pakistan, yeah, amazing, yeah. We have...
Honestly. Honestly, wow.
Okay. So, please let me read the curriculum vitae, of our speaker this morning. So let me share my screen. Sorry. So I've give you the link of the YouTube channel. So from now on, we could get benefit, the information and the material from the YouTube channel of Dr. Adeleye. Thank you very much, Dr. Adeleye, for creating and producing such that's wonderful masterpiece, I think. And now we can get benefit from you through your YouTube channel. Yeah, it's very, very beneficial for us. So Dr. Adeleye is the lecturer and researcher in the Department of Economic and Development Studies, Convenant University, Nigeria. Yeah, so her specialty is on applied econometrics and doing multidisciplinary researcher. Yeah. So her core competency is applied econometrics, microeconomics, modeling, and she's also doing having a lot of open online course development. So she has proficiency with Stata, AViews, Excel, of course, and SPSS and R. Yeah, R application. Yeah, basic R. Her research interests, in case all of you have the same interests, yeah, we can do future collaboration in development economics, yeah, energy and environmental economics, yeah, institution economics, agricultural economics, yeah, financial economics, and also health economics, yeah. I'm not sure what's ICT 4D. Could you give us some information on that, Dr. Adeleye?
Okay, it means ICT for development, information communication technology for development.
Okay, thank you very much. Information and communication technology for development. Yeah. Okay. So, and so I'm sorry I cannot read all of this for all of you, but for sure she has done a lot of accomplishment. So we're very happy to have Dr. Adeleye here with us, so he could share some of her expertise in the topic of quadratic modeling for this morning. I think that's all for some introduction, yeah, some short introduction, because I believe we still have many of her works that we haven't known yet. Perhaps we could get more during her lecture. Okay. Okay, I think I will not take too much time for this morning, and I would like to please Dr. Adeleye to start your lecture, and please, the time is yours, Dr. Adeleye.
Thank you so much, Mubin. I'm so excited to be here. Let me just ask before I begin, how many minutes do I have for the presentation?
Okay, so for the presentation, I'm sorry, you have like 75 minutes, yeah, 75 minutes, and we have half an hour for question and answer. Yeah.
Perfect. Okay.
Okay.
Okay. So I have some 5 minutes to present. That's nice. Yeah. Okay. That's all right. Okay. First and foremost, I want to say thank you so much for this opportunity. I'm so excited. I don't even know what to say, honestly. First and foremost, I want to thank Universitas Airlangga. I hope I got that correctly.
Yeah.
Did I pronounce Airlangga? Okay. I want to thank you all for this invitation, for giving me the opportunity to speak to students, to faculties, for giving me another opportunity to teach the little I know. I keep telling people, nobody knows it all in any field, particularly econometrics. You only know to the extent of whatever technique you are using. I tell people there is no professional in econometrics. You can only develop yourself to the best of the techniques that you are using. So it's still a learning process. I'm still learning. I'm also a student. So thank you so much for the opportunity to teach the little that I know. And I also want to thank the department for putting this event together to add skills to the students and to us and to the lecturers too. You know, there is no knowledge that is wasted. So opportunities like this is always very, very welcoming. So thank you so much to the economics department. I also want to send my gratitude to Dr. Kabiru Anafi Ibrahim. It was Dr. Kabiru that nominated me for this guest lecture. Honestly, Dr. Kabiru, I don't know whether you are online, but if you are and if you are not, I'm saying thank you for the opportunity. Because if you had not recommended me to University of Airlangga, I won't be here today. So I want to say thank you for the nomination. I am very, very grateful. I also want to appreciate my Crunch Econometrics family. I can see, I have so many families all over the world. I can see Dr. Anupam Dalal. I can see Dr. Usman. I can see Dr. Adepoju from Nigeria. I can see Joe from Nigeria. I can see Dr. Ogede. I can see Praise from Nigeria. Thank you so much for the home support. I can see gifts. Thank you, thank you, thank you. I am so, so grateful. And to everyone who is able to be here today, it's going to be a wonderful moment. We are all going to get value for what we are going to learn today. For every information that will come across from me to you, I am so confident that going forward, you are going to have a better input into your research. By the time we are done with information on quadratic modeling, you'll be able to improve your analysis and your modeling going forward. So once again, thank you so much. I am very grateful. And to all the lecturers of University of Airlangga present today, I want to say thank you. And just like Mubin said, I pray that going forward, we'll be able to have collaborations between us and push the agenda forward. Thank you. So without so much ado, let me show my slide and we get the presentation going. So I'm going to share my screen now. This is going to be a hands-on presentation. Even though I have done all the analysis, I'm still going to show you how I came about the results so that you can all replicate the analysis. And before Dr. Rosanto excuses himself, I'm going to send the data and the codes to him so that he can make it available to all the participants, to the students, to the lecturers, so that they can replicate and practice, you know. This is a live data. I use a live data for a country, but I hit the identity of the country. So this is a live data, and every result here is a live result, okay? So you are all going to have the data so that you can practice and see whether you can get the results that I got. Once you can do that, you can just simply replicate it to your current research. Okay, let me start. So like I said, it is going to be a practical hands-on lecture. I'm a practical person. Whether I'm teaching in class, whether I'm teaching online, I always engage the students. I use what they call learning by doing, okay? So it's going to be as I'm teaching, make sure you do it as long as I do it. So if you are hearing me right now and you have your data, you can just put your data up and begin to use the knowledge you are getting and see maybe you can make sense of your research right now, okay? So let's make it hands-on, let's make it practical as much as we can. So I'm going to be talking about quadratic modeling and applied research. We'll look at the benefits and the relevance. And the objective of this topic is to offer researchers the necessary skills so that they can independently deploy econometric techniques to their current research. It is also to enable them understand and evaluate different data analysis as published in the academic literature. So that after today, if you pick up any publication, you'll be able to understand the analysis and also to interpret the results. As a prerequisite, it is important that everyone should have a good working knowledge of at least the ordinary least squares. At the minimum, have an understanding of the OLS regression model. So for simplicity, the entire training of this morning will be based on the OLS technique, okay? So the quadratic modeling will be on the OLS application. just to simplify understanding. Once you understand it, then you can deploy quadratic modeling to any other regression model. And you're also required to have some knowledge of statistical software, Stata, eViews, R, SPSS, and all that goes with it. For me, I'm most familiar with Stata. I can say Stata, I'm like 80% on Stata. eViews, I can give myself 75%. On R, I'm still a baby in R. So maybe R, maybe 20%. So as a researcher, it is important to have at least one or two of this software so that you can practice and hone your skills as you improve yourself in the research world. The learning outcome for this guest lecture will be for you to understand the relevance of why you are using a quadratic analysis. Then you will be able to know how to specify quadratic models, interpret quadratic models, and determine your turning points. Quadratic models can be deployed if you are doing a time series analysis or whether you have a panel data analysis. I hardly use cross-sectional data, so that is why most of my tutorials, you hardly see cross-sectional data. But if you are using a cross-sectional data or survey data, you may try this modeling and see whether it works for your data, okay? So I'm only going to speak to the panel, the data structure I'm most familiar with, which is time series and panel data. So if you're a cross-sectional data analysis, you can try whether this quadratic modeling will work with your study. All right, let's dig in. Let's look at the relevance of quadratic modeling. Perhaps you want to examine if the relationship between two variables, y and x, is nonlinear. The literature, for the most part, often says there is a linear, direct relationship between x and y. X in this case being the independent variable, y is the dependent variable. So maybe in your own case, you identify a gap in the literature and you want to probe further and say, wait a minute, what if the link between y and x is not a linear relationship, but non-linear? In that case, you want to see whether there is an increasing or decreasing monotonic relationship between the two of them. What do I mean by that? You want to see if x keeps increasing, what will happen to y? And if x continues to decline, how will y respond? So you want to see if by increasing x, will y maintain an increasing rate or a decreasing rate? So that is why we are having a quadratic modeling. Or maybe you want to establish if the relationship is even parabolic. Maybe it's not increasing or decreasing monotonistic relationship. Perhaps it's parabolic. In this case, you want to see whether y will respond differently with each increase in x. And maybe you just want to expand the frontiers of knowledge. Sometimes research is just for you to engage your curiosity. You are curious about a relationship and you got your data and you put it to test. So maybe by that, you may end up expanding the frontiers of knowledge when you deploy quadratic modeling. So these are some of the relevance of deploying quadratic models. On the screen is a typical quadratic model specification. A typical quadratic modeling specification. In this instance, we can see variable CO2 in natural log. We have variable trade in natural log. We have trade squared in natural log, we have GDP in natural log, and we have population in natural log. So from equation 1, CO2 here is a dependent variable. Trade is the main independent variable, that is a variable of interest. GDP and POP, these are the control variables, okay? So what am I testing? I'm testing whether there is a trade emissions environmental coordinates relationship. This is what equation 1 is specifying. Okay, so I want to see if there is a form of EKC relationship between trade and carbon emissions. And when you have an equation like equation 1, the parameters of interest are just 2, θ1 and θ2. Among all the parameters I stated here, from the intercept of the model, from θ1 then to θ4, you are only interested in the sign and the statistical significance of θ1 and θ2. So anytime you specify a quadratic model, look out for the sign upon estimation and the statistical significance of these 2 parameters, θ1 and θ2. That is what would determine whether the relationship between trade and carbon emissions is increasing monotonic or decreasing monotonic, or whether it is parabolic. Now let's look at some of these specifications here. Let's look at number 1. In number 1, I said, if θ1 is less than 0, that is, if θ1 is negative, and θ2 is greater than 0, that is, θ2 is positive, we are going to have what we call a U-shaped relationship. A U-shaped relationship in the sense that θ1 falls, then at a point, θ2 increases. So that is a U-shaped relationship. So upon estimation, look out for the sign and statistical significance of θ1, and same thing for θ2. Let's look at the second specification. θ1 is positive, greater than 0. θ2 is negative, less than 0. At the end of the day, you are going to have what we call the inverse U-shaped relationship. Remember, the inverse U-shaped relationship is the coordinates hypothesis. That is the coordinates curve. You know, the original coordinates curve looks at the relationship between income inequality and economic growth. And from there, we have different variants of the coordinates curve or the coordinates hypothesis. And one of the most popular is the environmental coordinates curve. So anytime you have θ1 being positive and θ2 negative, you have an inverse U-shaped EKC relationship. Let's look at the third specification. Both parameters are positive. θ1 and θ2 positive. So what does that tell you? It tells you that there is a monotonically increasing linear relationship between trade and emissions. Let's look at the fourth specification. θ1 and θ2 are both negative. So what does that tell you? There is a monotonically decreasing linear relationship between trade and carbon emissions. Let's look at the fifth relationship. What if after estimating the model and you have no significant relationship? What does that tell you? After estimating your model, the coefficient of θ1 is not significant. Also, the coefficient of θ2 is not significant. It simply means they are equal to 0. Okay, I'm going to talk about that in the course of the lecture. So θ1 and θ2 equals to 0 simply means both coefficients are not statistically significant. So they are not different from 0. So it means there is a levels 0 relationship, okay? So I took time to explain this so that after estimating your model, you can easily determine the shape of the relationship between trade and carbon emissions. Also, when you specify a quadratic model, you can derive what I call the turning point. The turning point is a very beautiful way of discussing your results, particularly when you have a parabolic relationship. And you can only get turning points when you have these two outcomes. When θ1 and θ2 have different signs. Please try to take note of that. You can only get turning points when the outcome of θ1 and θ2 indicates that both of them have different signs. They have different signs, and they must be statistically significant for you to conclude that there is a turning point. Let me take that again. θ1, I'm going to show you the results as we move along. θ1 and θ2 must be statistically significant, and they must indicate different signs for you to conclude that there is a turning point in the model, or that there is a turning point between trade and carbon emissions. So θ1 positive, sorry, θ1 negative, looking at the first specification, and θ2 positive, like I said before, is a U-shaped relationship. And θ1 positive, θ2 negative is an inverse U-shaped relationship. By way of emphasis, this is the EKC relationship. So you derive the turning points when you have these two outcomes, or any of these two outcomes, okay? Now, for you to calculate the turning points, it's very simple, very, very simple. What do you have to do? You take the first derivative of equation 1. You can do it right now as you're listening to me. You can write out this equation on the paper and take the derivative. I want everyone to do it, if you don't mind, so that you can actually understand the turning points and you can be able to calculate it yourself, okay? So write out equation 1, then take the differential with respect to trade. I'm using log, so make sure you differentiate equation 1 with respect to the log of trade and set it to 0. It is important you set it to 0. Once you have done that, you are going to find the optimal points. I'm going to show you how to do that too. You will find the optimal points. Once you have obtained the optimal points, because I'm using the natural log of these variables, it is important I take the antilog or exponent for me to obtain the real value and confirm if that value is within the range of values of trade. Let me take that again. From number 2, I will have to take the antilog or exponent of the value of the turning point, which is a natural log, so I can obtain the real value. And the reason for this is that I can confirm that the real value lies within the range of values for trade in this example. So I can confirm that from the summary statistics. I'll show you all this as we go along. So make sure you practice. Let's make it hands-on as much as we can. So everything I said in the previous video, it's all on the screen. So look at what you did and confirm if you can get what I got. Equation 1 is still here. I took the first derivative with respect to trade, all in log, and I set it equal to 0. So if you did it correctly, you should have what I have in equation 2. Differentiate equation 1 with respect to trade, you should have what I have in equation 2. Now, to find the optimal point of trade, all you need to do is to get equation 3. And how do you get equation 3? Just simply move everything here to the right side, okay? Then divide both sides by the log of trade and you have equation 4. So equation 4 star denotes the threshold of trade openness, beyond which it reduces or exacerbates carbon emissions. So the optimal point of trade shown in equation 4 will give you the threshold points of trade openness, beyond which it either reduces or exacerbates, increases carbon emissions. I'm using the word "or" because we have not estimated the model, so we cannot be exact, okay? So equation 4 will only give you an idea of how you are going to interpret your turning points. Will emissions be increasing if trade goes beyond those points, or will emissions reduce if trade goes beyond those points? So that would depend on the signs of θ1 and θ2. Okay. Still on deriving the turning points. Remember I said the turning point is derived based on the sign and significance of these two parameters, θ1 and θ2. And they must have opposing signs. They must have opposing signs. If you look at these two equations, let's look at the first one. θ1 negative, θ2 positive. Remember, you have a U-shaped relationship. Now, the turning point is going to give you 0.5 θ1 over θ2. This is what you're going to have, okay? 0.5 multiplied by θ1, θ2. That is the optimal point. If you look at the second specification, when θ1 is positive and θ2 is negative, remember I said this is the E-case relationship. The turning points calculation is still going to be the same. You can try it, okay? You're going to have the same 0.5 θ1 over θ2. What am I trying to tell you? It doesn't matter the signs of these two parameters. Your calculation will give you a positive, turning point. It must be positive turning points, okay? Depending on the data you are using. Let me put a caveat. And remember, for you to locate that turning point within your data, if you are using a log value, make sure you take the exponent so that you can convert back to the log, to the real values, as written here. Take the exponents and convert back to real values. Okay, now let's move on to take an example. I have one example here. I use Stata and I use eViews. So let me start with the Stata version, then I'll move on to the eViews version. Okay. So in this example, our objective is to examine if trade openness contributes to environmental degradation and if there is a non-linear relationship. So if you're lucky to be working on a similar project like this, you can now begin to see whether you can include a quadratic model, okay? The first objective is to examine if there is a linear relationship between trade and environmental degradation. This is what the literature is familiar with. But in this case, we want to expand the literature to see whether there is a non-linear relationship between trade openness and environmental degradation. The data I'm using is for a country Z. Like I said, it's for a real country, but I'm hiding the identity of the country. This is a live data. I got it from World Bank, World Development Indicators. And the dependent variable, which is the proxy for environmental degradation, is carbon emissions per capita. I'm using carbon emissions per capita. And the main independent variable is trade openness as a percentage of GDP. Well, I decided to include two control variables, GDP and population. So in my own case, I decided to just specify a parsimonious model, just 4 variables in total: carbon emissions, trade openness, GDP, and population, to unravel if trade exacts a non-linear relationship with carbon emissions, which is the proxy for environmental degradation. So what do you have to do? As a researcher, as a student, you have gotten your data and you want to establish a nonlinear parabolic or a nonlinear monotonic relationship. What do you have to do? First thing first, perform your summary statistics. Assuming all things being equal, if you're doing a time series model like this, I will believe you've done your unit root testing, you've done co-integration, if that is the way you want to go. Then you move on to establishing the historical statistics of this data. I'm going to emphasize that when you want to perform summary statistics, even if you're not doing a quadratic modeling, please use the raw data to perform your summary statistics. I've seen so many publications where they use the log values of the variables to perform summary statistics. And honestly, it doesn't make any intuitive sense. That is the truth. If you want to run your summary statistics, it is important, advisable, knowledgeable for you to use the raw data itself for the summary statistics so that you can retain the historical properties. Then run your regression, observe the signs of the coefficient of interest. The coefficients of interest in this case are the coefficients of trade openness. Thereafter, you determine the shape of the curve. You proceed to compute your turning points. After that, you confirm whether the turning points lies within the range of values for trade, which is a variable under examination, from the summary statistics. Then you proceed to interpret your results. Quadratic modeling is beautiful. It makes your work more interesting and it gives more information about the investigation being carried out. So I will encourage you from today, if you have not been doing quadratic modeling, please try it out on your current research. Include a quadratic specification and begin to interrogate your results. So I'm going to move over to Stata any moment from now to show you exactly what I did. Okay, these are the results. So let me pause it here and just move over to Stata. So I'm going to show the underlying data first, then we move over from there. So I'm going to I'm going to share my screen to show the data that I'm using so that we can all be on the same page. I hope it's this. Let me see. Okay, great. So this is my stator. It's up and running. Please let me know if you can see my screen, but sometimes you can't tell. Mubin, can you see my screen?
Yes, the screen is there. We can see.
Perfect. Thank you. All right. Perfect. So this is the data I'm using. It's a time series data for a particular country from 1960, and I think it's to 2018, as you can see right here. So I have 1960 to 2018. This is the data for carbon emissions per capita. This is the data for trade openness, data for GDP, and data for population. Then here you have the natural log transformation of the variables. There are so many advantages of using natural logs, okay? It controls for, among others, it controls for noise, it controls for heteroscedasticity. Taking the log of a variable in a model allows you to establish elasticity relationship. So whether you are using a double log model or a semi-log model will depend on your modeling structure. So there are so many benefits of using natural log, okay? Particularly controlling for noise. Remember, all these variables have different measurements. So these are the natural logs. Then at the last one here, I took the square of the law of trade. I will tell you why I did that as we proceed in the lecture. So this is the data editor for Stata users. When you have the data, I'm going to give to Dr. Rosanto. So when you have the data, you are going to have exactly what you are seeing on the screen. Now let me show you the do file. I will also make the do file available to everybody so that you can replicate what I did. So from the do file, this is how you can create. There are so many ways of creating logs, okay? So just to keep it simple, this is how you can create the log of a variable. Can you all see it? I hope it's not too tiny. Mubin, please, can you see what I just highlighted? Let me know. Can you see this?
Yes.
Okay.
Yeah,
okay. I just want to be sure. There. Okay, I just want to be sure that it's not too tiny. Okay. So this is how you can create the log of a variable in Stata. There are so many ways, like I said, but this is one of the simple ways of doing it. So this is the log of COT, the way I created it. Here is the log of trade, log of GDP, and log of POP. This is how I created the square of trade. How you create the square of trade is very important. Thank you so much. Yes, thank you. How you created the square of trade is very important. I'm going to do something here now, as you can see. Some people create it this way. I have Jen. I'm typing something now. I want to create the log of trade, Jen to, let me call it Jen squared. Okay, trade squared, SQ. Please, can you move this red line a bit? Can you remove this a bit? Can you move this away, this red?
Yeah.
I'm typing something. Can you remove it? Can you move it away? Yes, thank you. I'm going to generate another square of trade. And this is where some students make mistake. This is what they do. They want to generate the square of the log of trade. And they do this, equals. They do log. And then they come and put trade times trade. If you do it this way, it's going to give you multicollinearity. So this is very wrong. This is the wrong way of generating the square of a logged variable. If you do it this way, you are going to have collinearity in your model. So this is wrong. So I'm deleting this. So this is the right way for generating the square of trade. Now, I'm going to move now to this, where I used the log. For us to specify quadratic model, remember we are having two objectives. The first one is to establish relationship between trade and environmental degradation. So this is the first equation for that. The equation for the quadratic modeling is this one. Here you can see trade and the square of trade. Let me repeat again. The first one is the linear relationship between trade and environmental degradation. The second one is the quadratic model, where you specify trade and the square of trade as regressors. The code you are seeing under, these are the code by which you can put the results in a good table, as you see in published articles. So that is why I always use Outreach too. There are so many ways you can export your results, but I find Outreach 2 very simple to use. So now, if I highlight all this, but before I highlight, I need to inform Stata I am using a time series data. So I need to run this code, tset here. I'm running tset here because my time is defined by year and I'm using a time series. So I'm telling Stata, set my time series to keep me running. So I'm going to highlight this and execute. So let me show you what I have on Stata after executing that command. Let me do that again. Let me put it to the side to see my file. Okay. Let me run this tset here. So you can see right here, Stata is telling me I have a time series structured data from 1960 to 2018. So we are good to go. So back to the do file. This is the code I'm going to execute. The code I've executed that, so let's go to the results. I click on this table. My results are now in a table format so that we can clearly see what we have. I click on this. And here I have the results. Let me expand it. Let me clean out irrelevant spaces. Good. So this is the results. This is what we are interested in, the quadratic results. Remember, the first equation, let me call this the linear equation. And the second one is the nonlinear equation. Nonlinear because I have included the square of trade in the model. So there's a difference between the two of them. This is equation 1 as specified in the do file, and this is equation 2. So equation 1 addresses the first objective, and equation 2 speaks to the second objective. Remember, our interest is on the quadratic model. So as a researcher, I may decide not to specify equation 1, okay? If my interest is only to establish if there is a non-linear relationship, I'm okay to specify just equation 2. So it is not compulsory you have the two equations. It is not compulsory. But if you want to have the two equations, all well and good. You have to be careful in your interpretation. For instance, for the first one, you are only going to determine a percentage change in trade, resulting to a change, a percentage change in emissions for the first one. Remember, this is a linear specification. So what does that tell us? A percentage change in trade openness will increase emissions by 0.07% on average ceteris paribus. Let me take that interpretation again. For the linear interpretation, you are going to say that a percentage change in trade openness will give you a 0.07% increase in either environmental degradation or carbon emissions. But when you are interpreting your quadratic results, you are going to consider the sign and statistical significance of the variables of interest, this and this. When you are specifying a quadratic equation and you have this sort of results, remember, this first one captures θ1. So θ1 in this case is negative. This second result, this second coefficient represents θ2, which is the coefficient of the square of trade. So from here, even before I begin my interpretation, I can clearly see that there is a U-shaped relationship between trade and emissions. Have you seen it now? From the nonlinear specification, looking at the sign of θ1 and the sign of θ2, both of them are having opposing signs. And opposing signs in the sense that for the first one, there is a decreasing relationship, and at a certain point, it begins to climb up. So I can clearly see here that trade exhibits a U-shaped relationship with carbon emissions. So from here now, I'm moving over to the PDF file to wrap this up. All right, so this is the results I showed you in Stata. Our interest is on the second column. Our interest is on the second column. And you can see that when you use the outreach to exports code, it will give you something similar to what you see in publications. So you don't have to be doing all the stars and asterisks yourself. Okay. Now, remember that column 2 is our interest. We have determined that there is a U-shaped relationship, but now we need to make progress and determine the turning points. You can see from here, I wrote 3.001. How did I come about the turning points? You can compute the turning points manually, and Stata can also derive it for you. So I'm going to show you how I got the turning point in Stata. Back to Stata. So I'm going to derive the turning points using a very simple code. You don't need to worry, I'm going to make this code available to everybody, so you can practice and replicate your analysis. In Stata, you can obtain your turning points in 2 ways. Either you use the multiplicative trade code that generated, or you use what we call the functional form. This is a functional form. But I realized that the functional form is what works best. So I'm going to stick to this. So now, let's see how we can obtain the turning points the moment we observed that the sign of both coefficients are statistically significant. If the sign of both coefficients are not significant, the turning points will be inconclusive. But before I get to that, let me just show you how to obtain the turning points. So this is the states I do file. Let me move this up a bit, okay? So here I have, okay, good. So this is the code I'm going to run now. This is the code for the turning points. Once you have this code, just modify just some syntax peculiar to your work, okay? You don't need to destabilize everything. Just change the variables to suit your work, and you just execute the code. So I'm going to run this, and I execute this. So here you can see, I'm trying to see if I can move this away so it doesn't block the picture. Let me see. Hovering it. Okay, good. So here you have the turning points as generated by Stata. If you can do this and put this in your paper, I'm sure every reviewer or editor will like what they say. So let's go back to the code. The first line of the code is the simple regression, as highlighted here. The first line of the code is the simple regression. The second line of the code is the code that determines the turning point. You can see local, TP. TP here means turning point. You can see underscore beta. You are dividing the first coefficient of trade. You are dividing it by the coefficient of the squared term. Just look at it right here. The second line shows you are dividing the coefficients. That is, you are dividing theta 1 by theta 2. I think that explains it now. Okay, that makes it simple. You are dividing theta 1 by theta 2. Now let's look at the margin. From the margin, you can see I'm doing 116. How do I come about the margin? You obtain the margin from the summary statistics of using that of the log of trade. Let me show you what I mean. I'm going to do something now. Permit me to minimize this, please, if you don't mind. It's blocking the view. I'm going to do some LN trade because I want to determine the margin. So once I do some LN trade, you can see here that trade, the margin of trade is from 1 to 4.75 because I need to indicate the margin to plot this. If you don't specify the margin, it will be difficult for you to get this plots. So it means that the margin of the log of trade is from 1 to 6. Let's come back here and see what I mean. The log of trade, the minimum value of the log of trade is 1.84 and the maximum value is 4.75. So to be on the safer side, I'm using the margin 1 to 6. So this is why I decided to put margin 1 to 6. If you don't specify this margin, you will not be able to generate that graph, okay? The third line here, X line T point determines the exact turning point. This one gives you the exact turning point where you have the margin plot X line TP. And the last one is for you to save the graph. Okay, so let me go back to the graph again. So you can see here the turning point is exactly on 3.00. And if you are not so sure of the value, just go back to your results. Is there a way to move this? trying to move this away, and I don't want to close this. Okay. So you go back to your results, and you can easily see. I don't know where the noise is coming from. I'm trying to see where I got the 3.0. Let me see. Okay. Let me use the second code and see when maybe that's where I got this 3.0. Let me use this one. Let me run this. I'm using this upper code now. Let me click on this and see. Yes, this is where I got the second code. This is where I got the figure. Okay. So if you run the second code, this is what you're going to have. Okay. So whichever one you use is fine. Whichever one you use is fine. So if you are not sure of the exact turning point figure, if you come back to your results, you can see right here. This is the result for the turning point. So here we can see that the exact turning point is at 3.00. So this is a U-shaped relationship between trade openness and environmental degradation, or between trade openness and carbon emissions. Okay, let's wrap this up. I'm moving on to my PDF file. Can you see my PDF file moving?
Not yet, the
Okay,
PDF
okay.
file.
All right, okay. Let me go
Okay.
to PDF now. All right, sorry there. Where's my PDF? All right, so now you have seen how I came about 3.00. Remember, 3.00 is in log. 3.00 is in log. It won't make any sense for me to say the turning point is log 3.00. Fine, I have calculated it out to be 3.00, but I need to show my readers that this turning point lies within the range of values for trade openness. So what do I have to do? All you need to do is to take the exponent of the value. Taking the exponent of 3.00 gives me 20.124. Now, I need to find out if 20.124 is within the range of trade openness. So the only way I can do that is to go back to my summary statistics table using the raw values of the series of trade. And here I can see that the minimum value of trade is 6.32, and the maximum value is 116.048. So I can see that 20.124 lies within the range of trade, which is a good thing. Even though the literature, some people argue that your turning points can give you a value outside the range of data. Some people argue that, but for the most part, the literature agrees that your turning points must, at best, be located within the value of the explanatory variable. And this is what we have here. 20.124 is located within the range of values of trade openness. So this is what I showed you before. This is the table of results. By now you are familiar with this. And this is the turning point. So manually, I just inserted this one here. And this is what Stata gave us, 3.00. So putting the two graphs together, whichever one works for you, fine. Okay, so either you use the first specification or either you use the second specification, you are getting the same thing. And the turning point is at 3.00. When you take the exponent of that, like I said, we are going to have 20.124. So this is 20.124 of trade openness as a percentage of GDP. Okay. We are now moving closer to the interpretation. How do you interpret this? Remember, we are interpreting the nonlinear results. The interpretation you give the nonlinear results is totally different from the interpretation you give the linear results, okay? So how do you interpret this? It's very simple. You can simply say that at the initial start of trade, the level of carbon emissions decline. Remember that the coefficient of trade in the nonlinear regression is negative and statistically significant. So that is why we can say that at the initial start of trade, the level of emissions decline. But as trade progresses beyond the optimal point of 20.12%, as you can see here, indicated by these turning points, we can conclude that the level of emissions will rise, causing environmental degradation. The literature agrees that trade globalization increases carbon emissions, causing environmental degradation. The literature agrees with that. So several papers can attest to that. But by using a turning point, you can tell your readers that at a certain point of trade, environmental degradation happens. And using this data, I can tell my readers that when trade exceeds 20.12% of GDP for this particular economy, within the range of data, within the scope, we can conclude that environmental degradation will happen, given the rising rate of emissions. So you can see the beauty of engaging a quadratic modeling to test your hypothesis, going beyond what the literature says. Remember, the literature agrees trade and emissions exact a linear relationship. Fine, we agree. But now I am curious. I want to know the points beyond which trade actually causes environmental degradation. So this turning point tells me that initially, trade does not cause environmental degradation. Trade actually reduces emissions at the initial level of trade, at the start of trade. But when it reaches a particular point, emissions start to rise and environmental degradation happens. So this horizontal axis captures the movement of trade. The horizontal axis tells you the increasing trend of trade, while the linear prediction captures the behavior of carbon emissions. So you can easily see the U-shaped relationship between trade openness and carbon emissions. I'm going to do the same thing, replicate the same thing using EViews. Replicating the same thing using EViews. Permit me to minimize this if you don't mind. I'll come back to show my face. So using EViews, so for EViews users, you can also engage quadratic modeling. EViews users. Even though EViews is not as robust to using codes like Stata, I'm going to show you how I got this result you are seeing on your screen. So right now, I'm going to move over to EViews. So EViews users, you can also partake of this. So I'm going to share my screen where I have my EViews already. Where is it? Okay. Sharing my screen now to show you my EViews. So let me delete what I have before. So right here you have the data. So you can see my range of data from 1960 to 2018, similar to what I showed you in Stata. So a total of 59 observations. So here I have a combination of the raw variables and their natural log form. For those who don't know how to generate the log form, let me just give you an idea here. You click on generate, and let me see if I can generate CO2 again, but I will delete it. So I want to generate the log of CO2. So all I need to do is just type ln CO23 equals, then I put log, and here I have CO2. I hope I got this correctly. So I want to generate the log. I don't want to use log of CO2 because I have it here already. So I'm using a different figure. So log of CO23. So log of CO23 equals log of CO2. So if I click OK, so here you can see it, LNCO3. So this is how you generate the log of a variable. I'm deleting that now that you've seen it. Okay, so now let me show you the data. I have, I'm going to open the data now as a group so that I can see what I have in areas. So I'm going to press down the shift key. I'm pressing down the shift key. I click on the variables, picking them one after the other. I have log of CO2. I have log of trade. I have log of trade squared. I have GDP, log of GDP, and I have log of POP. So I've highlighted all the variables. I right click. Let me do that again. I press down the shift key, CO2, trade, trade squared, GDP, and POP, population. I right click, and I open as a group, okay? Just for you to see what I have as a group. So this is what I have. Similar to what I showed you in Stata. Data ranges from 1960 to 2018, right here, 59 observations. Okay, now let's get to work. For us to run the model, I click on quick and I go to estimate equation. In this case, I'm going to run the first model, which addresses the first objective, and which is to look at the linear relationship between trade openness and environmental degradation. So I start by specifying LNCO2, which is a dependent variable. I space it. I can put my constants. Then I type in the trade variables, LNCR. This is for the first one. Then I type in LNGDP. And then I type in LNPOP. I want to control for heteroscedasticity in this model. So I come to options. I click on this covariance method and I change from ordinary. I can decide to use Huber-White, okay? So I'm controlling for heteroscedasticity. I'm choosing the Huber-White to control for it. So everything looks fine. I click OK. Method here is least squares. I don't want to forget that. Just running a simple regression, okay? Assuming all things being equal. I click OK. So this is the result that addresses the first objective, establishing the linear relationship between trade openness and environmental degradation. And similar to the results that we got in Stata, our coefficient of interest is this one, the coefficient of trade openness. And remember the interpretation. Because we have a log model, a double log model, an elasticity model, the interpretation is very, very simple. Simply say a percentage change in trade openness results in a 0.07% increase in carbon emissions. And you can see that the coefficient is significant at the 5% level. So trade increases by 1%, will result in carbon emissions increasing by 0.07%. Very simple. Now let us move on to establish if there is a quadratic relationship or a non-linear relationship between trade and carbon emissions. So I click on estimate right here, and I just modify this specification by including the square of trade. That's all I have to do. By including the square of trade, I have modified a non-linear model or a quadratic model. Everything looks fine. I'm not changing anything. I click OK. So here is the quadratic model. And our variables of interest or coefficients of interest are simply the coefficients of trade and the square. And looking at the sign, you can clearly see that they have opposing signs, and both of them are statistically significant at the 1% level. So from here, even before I begin my interpretation, I can see a U-shaped relationship between trade and environmental degradation. So I'm moving over now to PDF to wrap this up. The interpretation is very similar to what I gave in Stata, so nothing new, but emphasizing is still in order. Okay, so I'm going to share the PDF now, and we conclude this lecture. So this is what I showed you from e-views, putting the results side by side. The turning point is very simple to calculate. I think I have it in Excel. I'm going to show you what I did so that you can also generate the turning points yourself. You can easily generate the turning points if you don't want to use data. So this is my Excel sheet where I calculated the turning points manually, okay? So what did I do? In computing the turning points, I only need two figures, just two figures. I need this one. Remember, I'm working with a nonlinear model. Let me indicate that again so that you can see the one I'm working with. So I only need two figures here. I need the coefficient of trade, and I need the coefficient of the square of trade for me to compute the turning points. And this is it. If you look at my formula here, you can see 0.464 divided by 2 multiplied by 0.774. If you go back to the specification I showed you when I began this tutorial, this is clearly how the derivative of equation 1 with respect to the log of trade will give you. So this is theta 1, and the denominator is theta 2, and this is 1/2, which captures the 0.5. Okay, so you only need two figures to obtain the turning points. So manually, when I got it, I came about 2.9974, which is approximately what Stata gave us as 3.00. So for e-views users, I don't have the code to generate this. If you do, that's fine. But I only brought it here as emphasis. This is what I generated from a Stata. So if you know you are very good in e-views and you have the code to generate this turning point, that's fine. But even if you cannot generate the graph, let me say this to everybody. Even if you cannot generate the graph, that's fine. Just interpret your results. Interpret your results so that your readers can understand these results going beyond the coefficient. Don't just stop at displaying the results, compute the turning points. And the turning points will make intuitive sense if both coefficients are statistically significant. So this one is for Stata, same thing here for e-view. This is the e-view's raw results, okay? It's the same thing I showed you from e-view's platform. So the only coefficients you are interested in are these two, nothing more. These two is what is relevant in computing the turning points. And you can see right here from the formula function. The upper part captures θ1 and the denominator captures θ2. The 2 here, this is 1/2, which represents 0.5. So this is how you calculate the turning points if you are using AVIOS. I'm going to emphasize again, if you don't have, if you cannot generate this graph, it's all right. Just interpret your results, okay? And make sure you can situate the turning points within the range of values of the data. What do you have to do? Just take the exponent of this log value and convert it to the raw figure for the variables of interest, in this case, trade openness. And by taking the exponent of 2.99, we are still going to have 20.12 something, which is within the range of trade. Please make sure you convert to the raw values to make your results more intuitive so that you can communicate the essence of having a turning point in log. All right, so all said and done. For AVIOS users, you can easily locate the turning points when you look at the summary statistics of trade using the raw figure. By now you are familiar with these, all AVIOS users. This is what you get from summary statistics. So I just decided to put both the log form and the raw forms together. So from here, we can locate 20.12 within the maximum and minimum values. From here, you can see minimum value of trade is 6.32, maximum is 116. So between them, you can locate 20.12% percentage of GDP. So anything beyond this point, environmental degradation will occur as trade increases. So environmental degradation will occur as trade increases beyond the turning point of 20.12. And you are confident enough to tell your readers that these turning points can be located within the range of values of trade openness, which is right here. Minimum is 6.32, maximum value is 116. So the turning point lies within this range of values. So this is just to put everything together on one paper. Remember, this graph is from Stata. If you can get the graph drawn for you by somebody, if you have a friend who uses Stata that can run it for you, all well and good. But if you don't have this graph, it's also fine. Just interpret your results and you move on from there. It's the same interpretation, similar to what I gave in Stata. Same interpretation. At the initial start of trade, the level of emissions declines, going by the negative sign of the coefficient of trade. But beyond the optimal point of 20.12%, represented by this turning point, emissions rise, causing environmental degradation. Similar interpretation, exact interpretation, a very simple interpretation. Okay, thank you for sharing the material. Appreciate it. Thank you. All right, thank you for listening. I'm grateful and I'm open to your comments and questions right now. Once again, I'm going to provide the data and all materials for this presentation to the head of department to disseminate to students and faculty so that they can replicate these results. Once again, I appreciate you for listening.
Okay, Thank you very much, Dr. Adeleye, for giving the lecture. And it's also some kind of workshop for us, because you required us to hands on the data and also on this data and the issues as well. It's very important to comprehend how to learn this kind of modeling. Now, we have time for question and answer. So I will invite all of the participants for raising your question to Dr. Adeleye related to the topic and material just has been presented. Okay, please feel free to raise the question or everything. Yeah, perhaps you have did something with this quadratic modeling and you find some other issue or something. Yeah, I think it's the best time to cultivate the best of quadratic modeling. This quadratic modeling.
Good afternoon.
We have Gabriel raising hand.
Good afternoon. Okay.
Good afternoon, sir. Good morning from Nigeria.
Yes. Good afternoon.
Okay. Oh, we have Mr. Pascual. Yeah, Pascual. Yes. Okay.
Good afternoon, Madam Prof. Adeleye. I'm Pascual from Timor-Leste. I'm very interested with your lecture. Actually, I'm accounting. I'm doing my PhD in accounting in UNAIR as well.
You're welcome, sir.
Yeah, and this is very important for me as a way.
Wow.
And collaborate with accounting to do something better in the future, especially for the budget or strategic planning.
That's
my
fine.
question is it's very interesting. And this new thing for me, but I'm very interested. This is not something very hard for me, but I used to study this as well with my prof, Fanani. He's the one teach us about this. I want to ask simple questions. As your data from 1960 to 1980, it means progress from time to time until 2018. What kind of area that show in your research, especially a contribution? In my university, my prof and my doctor, they asked about the contribution for many things about meteorology and novelty and anything that we can apply in practice. Me, Timor-Leste, part of a fragile countries, about 20 countries established in Timor-Leste 2010, just 7+. Yeah, this is a part of the combination about 1950 or 1950 years conference, Asia and African conference in Bandung. But we do small things from basic. Thank you. Just need one suggestion or insight that can encourage me to learn more about this, and then part of my subject and my accounting, my specialist in accounting. Thank you. Thank you, Prof.
Thank you. Okay, can I respond?
Yeah, you can respond it directly, Dr. Adeleye.
Okay, privately.
No, I mean right now. I mean.
Okay, that's fine. Okay, thank you, Mr. Pascal. I know students and researchers often have the problem of identifying or responding to queries about what is the contribution of the study. This is what I'm going to tell you. You can contribute to a study using the variables you are deploying. You can contribute by techniques. You can contribute by model specification, and you can contribute by scope. Let me give you an instance. Maybe Dr. Usman did something on trade openness and environmental degradation. And Dr. Usman covered from 1980 to 2018. So that means he's using maybe 40 years or 39 years. But I have decided to expand that scope to 1960 to 2018. I have contributed to the study. I have expanded from what Dr. Usman has done. Maybe Dr. Usman did not do quadratic modeling between trade and carbon emissions. I am contributing by saying perhaps there is a non-linear relationship between trade and carbon emissions. So going beyond what Usman 2021 did, I am including a quadratic specification. That is a contribution. Are you with me? So I can also contribute by I can also contribute by technique.
Yes.
Maybe Dr. Usman used ARDL, a single equation modeling. I may decide to use a non-linear ARDL or a quadratic ARDL. Is a contribution because we may not get the same results. Are you with me? So make sure you can contribute to a study in different ways. Don't let anybody tell you you don't have a contribution. Tell them I am contributing. Usman 2021 used 1980 to 2018. Adeleye 2022 is using 1960 to 2019 or 1960 to 2020. I'm expanding this scope of study to see whether there is degradation between trade, whether degradation worsens between trade and emissions. So contribution can come in variables, in techniques, in model, and in scope.
Okay. Thank you very much. Thank you very much, Prof.
You're welcome, sir.
Should I continue, Dr. Adeleye?
Yes, go ahead.
Yeah.
So I'm Gabriel.
Gabriel.
Just I am from Ethiopia, but I am like I have connection in LinkedIn. I saw your posts and I joined the.
Okay, your name, sir. I didn't get your name.
So my question is.
Your name, sir.
My name is Gabriel.
Okay, all right. Go ahead.
So I do have like two questions. The first thing is like in transforming the variable to logarithm to log forms.
Yeah.
I saw in some papers they multiply by 100. So like when they make it like log, like in yours, but multiply it by 100. I didn't, and in this case, like in your case, I saw like only forming, like changing, transforming to log. So does it have any difference making multiplying by 100, or simply we have to transform it by log only? Then my second question is, with the margins you said in the like in the quadratic form, like from paper to paper, I guess it will have a difference, yeah? In your case, you take like 6 margins from 1 to 6. So how do we decide to the margins is my question. Thank you.
All right. Thank you, Mr. Gabriel. Let me start with the log form. You can easily transform variables to logs using any analytical software. Why do you have to, why do I have to rack my brain multiplying by 100 when eViews can give me the log transformation, when Stata can give me the log transformation? Do you see where I'm going now? Mr. Gabriel?
Yeah,
so
yes, sir.
use the direct log transformation from your software. That is what I'm going to respond. From your software. I don't understand the multiplying by 100, I must confess. I want to transform my variable, I put it into Stata, I put it into eViews, and I get my figures. For the second one, for the margin, you can get the margin from the summary statistics. The margin is just to tell you the range of values of the variables. Okay, let me show you something. I'm still here, let me show you. Let me go to, perfect. Let me minimize this so that you can see. Now, look at trade openness. The minimum is 6.32, right? Maximum is 116. Sorry, not this one.
Yes.
The log is this one.
Yes, I'm watching. Yeah,
the log of trade, is this one, sorry. The minimum is 1.84 and the maximum is 4.75. Yeah. That's about 5. So I can say that the range of data is between 1 and 5, right?
Yes.
Good. So in my specification, all I did was just to use 1-1 interval. Remember, I did 1-1-6. Just to be on the safer side, 1-1-6. Let me show you.
Okay.
Permit me to pull up the do file. That's a very technical question, and that is fine. Let me show you the do file so that you can get the range correctly. Look at the do file. Look at the margin here. Have you seen it?
Yes, yes.
I'm highlighting.
One
so you can
like
see
in bracket, one in between, yeah.
Exactly.
The interval is 1-1, yeah.
Exactly. Exactly. So the lowest value is 1, the highest value is 1, and I'm putting 1-1 interval.
Yes.
I'm using 1-1 interval. If I have maybe 1 to 50, I may decide to put 5-5 interval to shorten the intervals. Do you understand now?
Okay. Yes.
So the figure in the center captures the interval perfectly.
Yeah.
Are you with me?
All right.
That was a very
Thank you
good
very
question.
much, Dr. Adeleye. Yes.
It's
Thank
all
you
right.
very much.
You're welcome, sir. You're welcome. All right, let me put my, okay. Any more questions? I'll do my best to respond. I'll do my best.
Thank you, Dr. Adeleye. Any other question from other
Okay,
participants?
I have a question. So I have a question moving from Joshua.
Oh,
from
yeah,
Nigeria.
yeah. In the
Okay,
chat.
have you seen it? Okay. Joshua is saying that what is the expected level of stationarity before we can perform the quadratic modeling? It's the same rule. Remember, this is a time series model. So your variables must be stationary. Your variables must be stationary. If I'm having a mix of stationary variables, it means I'm going to use ARDL model. If I'm having all of them non-stationary, whereby I differentiate and all of them are stationary at levels, I can decide to also use ARDL, since my focus is to look at the link between trade and openness. I may decide not to do a VAR. ARDL will still suffice whether you have a mix of stationary variables or you have all of them as non-stationary. You can still use ARDL model, which is a single equation model. So stationarity must also be in place before you can engage any time series model. Very important. Okay, Dr. Rosanto. Okay, all right. So Dr. Rosanto is about to leave, so I will send him the resource files to disseminate to everybody. Okay, any more questions?
Any other question?
I think it's all good. Maybe I gave a good explanation, so everybody is happy. Any questions, please?
Perhaps everyone is ready for using the quadratic modeling for their research.
So thank you so much. I'm grateful.
Okay. Yeah.
One question.
We have Mr. Joseph.
Yes, I'm trying to ask one question.
Okay.
What she has shown us today is on a quadratic model where we can see 4 variables included in that model.
Yeah.
But in a multiple regression model, is there any criteria or law in order to include what is the maximum number of variables or the variables or whether like independent variables that can be included in the model. What could be the maximum number of variables that could be included in a multiple regression model in order to interpret the findings? What you have shown us today is a quadratic model.
Okay, can I respond, Mr. Joseph?
Yes, thank you very much.
All right. I specified a multivariate model. A multivariate model, I have CO2 dependent variable as a function of trade, number one, as a function of GDP, number two, and as a function of population, number three. So in the simplest form, I specified a multivariate model. The model only became quadratic because I included the square of trade. It is still a multivariate model. Now the question is, how many variables do I include a model is subject to the interest of the researcher. But you must be guided so that you don't have too many variables in your model. There are two types of models. The first one is an over-parameterized model. The first one is called over-parameterized model. The second one is called a parsimonious model. Over-parameterized model and a parsimonious model. I'm going to type that out to everybody to read. Over-parameterized. From the name, over-parameterized simply means you have too many parameters in the model. You have too many variables in the model. And the second one is parsimonious model. A parsimonious model has few variables. And the literature has shown that parsimonious models behave better than over-parameterized model. Because you can't answer the question of the world. So many variables affect environmental degradation. If I put all of them in this model, the model will break down. And if you have too many variables in your model, you may end up having too many coefficients that are not statistically significant. You know why? Explanatory variables get feedbacks from one another, and they'll be sucking what I call significance from one another. Several factors affect carbon emissions, apart from trade, GDP, and population. I may decide to put energy usage. I may decide to put, what else? I may decide to put domestic credits, which is financial development. Several factors. The more variables I put in a model, it will weaken the power of the model. So I always tell people who ask me, I tell them, make your model as slim as possible. Maybe maximum 5 variables, 1 dependent, 4 explanatory, or maximum 6, 1 dependent, 5 explanatory, and that's it. The more explanatory variables you put, if you are not lucky, you will weaken your model. And when you get your results, it won't make any sense because all of them will not be significant. And when your results are statistically not significant, you have no results. There is nothing for you to interpret because you are simply saying that trade has no effect on openness, and that's end of story. So when a coefficient is not significant, nothing to interpret. And one of the reasons for that is when you have too many variables in the model. Another thing is that your R squared and your adjusted R squared in particular will penalize you. By using too many variables, your adjusted R squared will be reducing if those variables you are adding are irrelevant. That's another thing. So the more you add independent variables, your adjusted R squared will be penalizing you, it will be reducing. And if care is not taken, you will end up having a negative adjusted R squared. And when you have a negative adjusted R squared, you know that your result does not make any sense. So my advice to anybody listening, try to have a parsimonious model. Make your model as slim as possible to make it powerful, to make it predictable, to make it efficient. Do I answer your question, sir?
Yes, thank you very much. So it could be, it is like, for example, like in order to put it into a passing model, it could be like 5 or 6 variables could be sufficient to put into a multiple regression model, so that in order to provide a multi-collinearity problem, I think 4, like 5 or 6 could be possible, like just somewhere around there. I'm just trying to get an idea somewhere around there. So
5 or 6
I
is
asked
fine.
questions because
5 or 6 is fine. 5 or 6 is fine. Remember, in most cases, you only have one independent variable, the rest are control variables. So you're only interested in the independent variable. So the fewer control variables you have, the better for you. In this model, trade is my variable of interest. It is the only variable I'm interested in. But I'm controlling for economy and I'm controlling for population. So the fewer control variables I have, the better. My interest is on trade, not on population, not on GDP. You can see that I didn't even interpret those ones because they are not my variables of interest. So focus on your variables of interest and see whether your variable of interest is still effective, is still significant as you are adding control variables. The moment your variable of interest does not make any sense, it tells you you need to start changing your control variables. Perhaps there are too many, or perhaps you need to get better proxies, okay? So 5 or 6 is fine.
thank you very much. Thank you very much. I think I get a good understanding there. I've developed a model, so I'm trying to incorporate some of those variables or incorporate it into the model that I developed. So in case it might be more than expected, so that might cause multi-collinearity problems. So this is something of interest. So I'm asking. Thank you very much for your very
You're
informative answer today.
You're welcome, sir.
Thank you.
Okay, thank you, Mr. Joseph. And we have another question, from Mr. Onwe Joshua, performing IRDL. Could you please respond, Dr. Adeleye?
I've responded. Is it not? No, okay, using ARDL for quadratic. Yeah, you can use. Somebody's asking if you can use ARDL for quadratic modeling. Why not? You can. You can use it. You can. I have so many papers where I use quadratic modeling in ARDL, so you can.
So but how do you use it?
Okay, we have Mr. Muhammad Laminjabi. Do you want to raise any question?
No.
Okay. Mr. Muhammad, yes, please. Okay.
No, it's all right. I was not. It's not that I want to make any question.
Okay. Thank you. So, any other question from all the participants in this room? I think we have enough, Dr. Adeleye. So the participants have all delivered their question and all the response has been delivered. So I think it's a time for you. Maybe you give like some closing. I mean, some emphasis for this quadratic modeling, that we should remind, yeah, to be able to implement and get the benefit of this quadratic modeling.
Thank you so much. All right, as a recap, because I use the time series data, it is assumed that I've done all my unit root, which is fine. What you need to take home is that you need to know the summary statistics of the raw variables, and also the summary statistics using the natural log, so that you can determine the interval and range of values when you obtain the turning points. Okay, so in this example, I use a double log model. So my turning points was in log, or is in log. 3.00 is in log. So there is no way for me to interpret that. It won't make any intuitive sense. So what I have to do is to get the exponent and locate the real value within the range of value. So you need the summary statistics, okay? You need the summary statistics. And from the question of Mr. Joseph, try to specify a parsimonious model. In my own model, I use 4 variables. Maybe you can use up to 5 or 6, but focus on your variable of interest. Somebody may ask, but what if I use the level form of the variables? Yes, you can use the level form, but I chose to use the log form because it's simpler for me to use, and because using the log controls for so many diagnostics, even before I begin to test for diagnostics. It controls for noise, and it makes my explanation simpler, okay? But if you want to use the level, the raw form of all of these variables, yes, you can use that. So in that case, you don't need to bother about getting the natural log of the variable of interest and converting. All you need to do is just use the raw form, go to your table, and pinpoint your turning points, okay? But it's always advisable or better if you specify a log model to simplify your understanding. What students are often afraid of, or what sets them off, is interpretation. How do I interpret turning point? Remember, I said it's very simple. For instance, what if this was an inverted U-shaped relationship? What if it was an inverse? I will just invert my interpretation. I will simply say, at the start of trade, emissions rise, and trade gets to a certain point of 20.12%, then emissions start to decline, and environmental degradation reduces. That is if I have an inverse relationship. So it is really, really not difficult interpreting quadratic modeling. Let me take you back to the model specification as I wrap this up. It is very important in your section 3, for those writing manuscripts, you need this. You need this in your section 3. This one will explain to the reviewer that you understand what you are doing. You specify equation 1, which is the quadratic model. You specify equation 2 to show how you are going to derive the turning points. You get to equation 3, and equation 4 tells your readers that this is how you are computing the turning points. So this slide 10 of this PDF file is important for you as a researcher to capture in your section 3. And for those doing masters and PhD and undergraduates writing their dissertation, and you want to include quadratic modeling, I will encourage you to also include this under your model specification. It will tell your supervisor that you understand what you are doing. So with this, I say thank you very much, and God bless you all for listening.
Thank you very much, Dr. Adeleye, for very fruitful and beneficial lecture, and also some workshop this morning for all of us. And we from Department of Economics, Faculty of Economics and Business. As our head of department said, we really appreciate and we're really grateful for the event and for the lecture this morning. So we wish all the participants can get the benefit and use this model for their research, for enhancing their research, so they can finish their dissertation or they can publish in their journal, their favorite journal. So it will be the benefit of the lecture this morning. Me as the moderator for this event, for this lecture, sorry if I cannot handle the forum not good enough, but I wish the best to all of you. Have a great day to all of us. Looking forward to see you in the other lecture, guys lecture, and in the other forum. Thank you very much and good afternoon for all of us. Assalamualaikum warahmatullah.
Thank you. Bye.
Thank you once again, Dr. Adeleye.
Thank you
Goodbye.
so much, Ruby.
Thank you so much.
Bye-bye. Yeah.
Bye-bye.
Hello.